A probability density function, or PDF, is analogous to a PMF, a probability mass function, but for a continuous random variable. So a PMF is to discrete random variables, as a PDF is to continuous random variables. So as an example, what I think is a fun example of a PDF is shown here. So height is a continuous variable. If you had a more and more precise ruler, you could continue to get a more and more precise height. So it's a continuous variable. We can represent it as fractions or decimals. And so here's a funny one where in the solid purple PDF that we have here, that shows the distribution of the height of American men. And then this dotted line shows the distribution of the height of men that they claim to have in the OkCupid dating platform. So pretty funny. You see height shifted 1 or 2 inches to the right on average. So we annotate a PDF with a lowercase italicized p. Like PMFs, we can distinguish different PDFs by the specific random variable that we specify inside of round brackets. And there are 3 essential properties of a PDF, just as there were 3 essential properties for a PMF. Like PMFs, PDFs must cover every possible value in the domain. So every possible height needs to be accounted for on this PDF. The probability of any given point on the PDF must be greater than or equal to 0. Third and finally, the integral of the PDF must come out to 1. So if we integrate over the entire shape of the distribution, it accounts for 100% of the possible values. So unlike a PDF, which has discrete points that we have probabilities at, because of this continuous random variable, if we want to find the probability over a particular range, we can use definite integrals. So the probability that x is between points A and B, so that x is, say, between 5'4" and 5'6", is determined by this definite integral. So these integrals, they're not critically important to your understanding of this PDF topic, but it's an example of one of the topics that we covered in the Calculus for Machine Learning live lessons that are available elsewhere. And so if you want to understand this completely, you can check those lessons out. So here's an example of a slide that we went over in those Calculus live lessons, which shows you how to calculate the area under a curve between 2 points using definite integration. And so this is the same technique that we would use to find the probabilities between 2 given points of interest on a PDF. Nice, so I hope that gives you a good understanding of probability distributions for both discrete and continuous random variables. Up next, I've got a couple quick exercises to test your comprehension.